everyone, I'm Nigel Watts and welcome to today's presentation on the ProtaStructure Suite 2024. I'm going to go through things very quickly today. We've got a lot to cover. It's very exciting. I'm going to give you a quick overview of Prota software, what makes us unique, show you some of the projects that have been used in real life, and then I'm going to take you straight into the software. Without further ado, let's get into it. So ProtaStructure is a unique system dedicated for modeling, analysis, design, detailing, fabrication and BIM. So this is a completely integrated platform for delivering projects very quickly and very efficiently. It's really about turbocharging project delivery, allowing you to go end to end on projects or use different parts of the system to suit your project needs. The idea behind it though is to really streamline processes, not losing information in silos, being able to quickly move from your design to your detailing to coordinating your projects using BIM technology. And it's a fantastic platform. It's evolved over many years and it's now being used extensively around the world. Key to ProtaStructure is the ProtaStructure Suite. So there's the ProtaStructure is the main platform for modeling, analysis and design. And this is complemented by ProtaDetails for detailing and drawing management, drafting, as well as ProtaSteel for connection design and steelwork detailing. To help you collaborate and coordinate your projects, we also have ProtaBIM, which in essence is a plug-in into Revit, but it's also the philosophy behind us being able to coordinate and share projects with a multitude of other different systems. This draws upon more than 40 years experience in development of structural design technology. We're now deploying the software to over 90 countries around the world, multiple language support. We've written numerous technical design guides and papers in supporting this. We've got a range of fantastic partners globally who are supporting our user base, and we've continued to extend the range of international design codes which we now support. In essence, this is the American, the British, the Euro codes. We've just introduced the Indian codes, which we're extremely excited about, plus all the other different variations that we see around the world. And we're expanding our reach. If you haven't got in touch with us before, we're a growing, exciting global business, and we are wanting to work with fantastic companies to help support them in turbocharging their project delivery. Now, don't take our word for it. This is being used on some very unique projects by some leading practices around the world. We've delivered major international airports. The largest terminal building in the world was designed in the ProtaStructure Suite. Large university, education facilities. We've even designed palaces, and the King's Palace in Malaysia is an example where they delivered a project with exceptional speed and quality in the Prota tools. Large commercial developments, hospitals, residential developments, mixed-use developments are the forte of the program. High-rise, low-rise, and everything in between. Ranges of different types of structural systems with beam slab, transfer plates, flat slab systems. All of this is covered by the system, and we also have a particular strength in seismic design and detailing. And this includes approaches for both retrofit as well as new technologies like seismic base isolation. Another interesting projects, airport buildings. It's a really interesting mix of both concrete as well as unique steel structures that we're seeing our user base deliver. It's really fantastic and exciting to see how people are deploying the technology. So enough of me talking. What I want to do is get straight into it today. Let's get into ProtaStructure Suite 2024. When you launch Prota for the first time, there'll be a welcome screen that greets you. In this welcome screen, you've got various information at your fingertips. If you're new to the software, there's getting started guides. There's what's new documentation that covers many of the new features that you'll find in ProtaStructure 2024. You also have access to the Help Center where you can submit tickets. You can also search for handy topics like, for example, I want to find out about flat slab design or raft foundations. There's lots of insightful information available in here. We've also published many design guides in here which cover various aspects of our implementations of various codes of practice around the world. I'd also, at this point, point out to you that you can also access a lot of information through our YouTube channel. So if you're not subscribed to this already, jump into YouTube, find the ProtaStructure channel and subscribe. This will give you access to a lot of the information that we provide, whether it's videos, training and tutorials. All of this is available here. You'll notice that the ProtaStructure Suite 2024 basic tutorial videos are already available. So if you want to find out more in detail, please take a look at this as well. And not forgetting our website. If you want to find out information, you can directly come into our website. Here you can sign up, subscribe and log into your accounts through here. All this is available at your fingertips too, and there's various resources in here. So for example, I want to go to some of the white papers that we've published. Okay, these are where there's many of these design guides I was talking about earlier. You can click in here and get straight into this. So that just gives you some background. Back to the software. I'm just going to create a new project, okay, and for the purpose of this demo, let's call it PS 2024. And when you do start, you'll notice that there's a range of different templates in here. Now these templates cover the typical design and detailing settings that you would use if you are designing projects in different parts of the world. So if I was setting up a project in, say, Indonesia, I might use the US codes together with the local SNI standards. If I'm doing a project in Poland, we may be using the Euro codes. If I'm in the US, we may be using the IBC imperial or metric systems. So you can come in here and choose these templates and they will load the typical design and detailing settings from where you are. So this is a great tool, especially if you're working across borders. Maybe you're based in Singapore but you're doing projects out of Thailand or the Philippines. You can grab these templates and they will cover all the localized design and detailing preferences will be adopted. I'm going to choose, for the purposes of today, I'm going to use the Eurocodes. I'm going to design this to the Malaysian National Annex, and I'm going to look at medium ductility for the Seismic. So I can just accept this and hit OK, and then straight away we're into the modelling interface. Now it's very straightforward. We've set this out logically. So along the left here you've got access to a tree where you can quickly access various information on components in the model. Along the top here you've got a ribbon, okay, that you can access. So in the starting point here is that you can import various information to get moving, whether it's a simple architectural drawing or physical information. You've got your settings center here where all the settings that we have for the project are centralized, and you'll notice here that there's various different codes of practice that you can choose from. If you do click on this, you'll notice that you can explore different implementations of codes. So whether it's the American standards, whether it's Euro codes, whether it's variations of these that may be in the say the Philippines or Indonesia or Peru, other parts of the world. You'll also, if you're from India, you'll also see here that we've implemented the Indian standards, and this is a very comprehensive implementation that's come with the 2024 version of the software. You can also access various other settings, detailing preferences, templates in here can be accessed, things like different patterns for things like detailing preferences, different ways of achieving curtailment. Okay, all of these are accessible here. For those of you who are familiar with Prota, you'll see that there's this new steel detail bars here, and you can play with the way in which you want bars curtailed, whether it's away from plastic hinge zones and the like. All of this can be customised to suit how you want to set up your detailing preferences. But typically when you load these templates at the start, we'll follow the local preferences that you have for the codes of practice in those regions. So now looking from along the top here, we've got modelling, so you can model your physical elements here, whether they're concrete or steel work. You can then assign loads, so whether it's seismic, wind and the like. You can check things before you get into the analysis and the design. You can also then document the project. So once you've done the design, you can create all your drawings, whether it's from ProtaDetails for your general arrangement drawings, your concrete detailing, or whether it's out to ProtaSteel for your connection design and your steelwork detailing right down to fabrication. All of this is seamless and you can easily communicate with different parts of the program. You can also seamlessly communicate with various BIM platforms, whether it's Revit, whether it's with our SAF exchange through to ArchiCAD, Allplan and other Nemetschek products, or whether it's basic exports out to IFC file formats or 3D DXF, DWG formats. All of this can be handled through here. We also have some very intelligent model exchanges with other programs that are used in industry. You'll notice here there's exports to ETABS, SAP, OpenSeas here. These are other platforms that are commonly used, and you're welcome to take advantage of these integrations that we have, being an open platform. I'm going to just start the modelling process at this point, and to do this I can create the model in a number of ways. So I could import information, as I mentioned earlier, from architectural drawings. I'm just going to create a basic model here, and I'm going to take you through this process step by step. So the first thing we can do in here is key in basic gridline arrangements. If you have these axes already in a drawing, you can import these and pull them off. Okay, so you can see an arrangement of grid lines here. These grid lines are completely adaptable, so if you wish to make changes in here, you can. I'm just going to tweak this grid line so that that you can see that this is flexible. So if you have maybe a curved axis that you wish to set out, you can. If you have unusual set out, this is also easily accommodated in here. So if I have grid lines that are not exactly straight, maybe we have an unusual set out, maybe dictated by the architect or the owner, you can come in and create whatever you like in here. And virtually any type of set out can be achieved using these the grid lines arrangements. So once you have a set out that you're happy with, we can then start to model other elements. So you can come in here and you can create columns, and to do that you can just click and insert columns. If you have a number of columns, you can create, or you can box around to put them in. Okay, if you wish to orientate elements differently, you can put in different orientations. You can also do smart things like align members along the curvature of, say, grid lines here. Now we operate Prota by using libraries, so we've got various physical objects placed in these libraries. So if I click on the properties, you can see that we've got a library of different concrete profiles here, different steel sections and steel profiles. There's a range of different steel databases here. Everything internationally is supported in here. You can also choose to create your own built-up sections, as well as draw from various cold form section databases, as well as create your own. You can also set up and create composite profiles where you may have, say, steel sections encased with concrete. So all of this is available here, and you can just draw from this library as you're creating your model and create these profiles. So I'm going to put in a circular column here. Underneath this, we're automatically calculating the engineering properties that you can use, and we can then start to model this and create this in the use this element in the model. So here you can see I've gone around and created some concrete profiles. Okay, I'm also at this point going to come in and create some walls, and I'm going to do a few things with the walls here, but let me just put in the basic outline here of some wall shapes. as I've done here. At this point I'm going to just offset an axis, so let's just draw this axis down, okay, and I've created another axis there. I could carry on, we could put another axis down further. These axes can be manipulated, so at any point you have the ability to be able to fully manipulate and change maybe the extents of the axes here. So I'm just going to stretch these and bring these in. Sorry, let me do that one more time. So we can just grab these two axes, we can stretch and move these in, as I've done here, okay, and similarly at the other end we can do the same thing on the other side. You can easily come and just play with these to insert them, to manipulate where you'd like to see them in the model. So I've got a couple of axes here. Now axes can be set up as dummy axes. These are essentially just to help you with the modelling. If we go to the member tables, you'll see the axes table here, and you can play with things like, if I quickly want to just change these so that there's no labels on them, okay, you can see that I've just set these up now, and they're essentially just set up as grid lines that I can use to help with set out. Now I'm going to take advantage of these, so if I just go back to the properties of that wall, now you can just select and load properties from clicking on an element. I'm just going to take that wall and I'm going to use it further here. So you'll see here that I've just grabbed that wall element and I'm using this together with the rest of the wall that we created earlier. So I've got a little bit of a different profile here, more of a sort of a C-channel with a flange that I'm going to take advantage of. And that might be a typical lift core. Okay, you can set up any type of profile that you like in here. I'm now going to work with beams, so let's just put in some concrete beams. We can key in the depth of the beam. Now to create beams you can box around to put them in. Okay, so you can happily just come and box around, set beams up in here. Okay, you can also click and create members as you go. So you can see here I'm just creating these profiles as I run around the building here. Okay, you can move and create members as you wish. So if you want to put in a curved member as you're going, you can easily come in and do this. Okay, you can also place members through elements. So here, so I'm just I'm going to, let me just change that. You can just come and place members through the elements. Okay, it will check for things like wall overlapping. Okay, you can be selective with how you model. Okay, if you want to put members through in this manner, you can do it this way. When you are creating, if you recall when I went back to the beams, I can also include things like wall coupling beams. So if I come back to the walls, okay, I'm going to change this to a coupling beam. And we can assign this element in here as a coupling beam as well. Okay, so quickly you can just come in and lay out sections to suit. We can at any point go back and just change that to a normal beam. Okay, let's just select the normal beam, and those profiles will be same. So it's understanding that we're actually modelling through the walls, so it's actually picked that up and it'll advise you. You don't have to worry about this. It's just there's no overlapping of the elements. We're just automatically creating those members without overlap. Okay, so I just come in here. You can see I'm quickly coming and creating these elements here. Now, at this point, if I'm looking at this introducing secondary elements, so at this point, if I'm looking at introducing secondary elements, I can just snap to points. I can put members in. Okay, I can just run around here and create what it is I want to see. Now, if you hit F2, you can actually key in and create a section exactly where you wish it to be. You can use your cursor keys just to realign the position of elements. So if I have an architectural drawing beneath this that I'm wishing to align to, I could easily do that. You can pick up sections, set multiple sections in fact, and just move these into position to suit the underlying architecture. Now you recall that I made this unique wall shape here. If I select this at this point, I have the option then, if I right click, to come in and merge these elements. So I've now merged that element, and that's now one singular core wall. Okay, and once I've done this, if I come, when I'm selecting the wall menu will open. You can see now that we have this Polyline wall editor. Now we've done a lot of work with this release, and we've enhanced the containment options here. So if I come in and I want to automate the containment, I could do things like add head zones. If I want to have concentration of bars around the ends of walls to take advantage of or to increase moment capacities, you can do that. If you hit OK, you'll see then that the head zones are set up. Okay, and if you mouse over, you can see where I've got the confinement, link confinements created in here. This is editable. You can make changes to this, but just with a click, we've actually created a template here that we can then use for designing these walls. And the program will optimize the design of the bars within the walls. Okay, it will try and come up with the most efficient design. This is really being used as a template. Now you can easily come in and change bars within the wall. It's easy to do, so there's new functionality around that as well. If I'm happy with this, I can just accept that, and then that element becomes part of the model there. Okay. I might at this point want to start to look at inserting slabs, and as part of this process, the software will ask us to help define combinations that we're going to use in the project. So I'm going to automatically generate the combinations at this point. The dead and live load cases are here. You can set up different pattern load permutations for Eurocodes. There's favourable and unfavourable factors that you would use. There's various other coefficients that would be set up here that the software will use to help define the combinations for you. Okay. Now you can run stage construction analysis here as well, and it will look at the time-based construction stages. You can use this if you're modelling very tall buildings and you're worried about differential axial deformation. That's another option that's available in here, and we will set up independent cases, or which could be looked at together with your gravity cases, or you can just have stage construction cases only. It's up to you. You can also create thermal loads. Lateral combinations are here, and you can set up and define various permutations of lateral combinations. There are different permutations. All possible permutations can be defined. You can also create your wind loading, which with the Eurocode is combined with notional horizontal loads. They'll also be established. If you have other things going on in the model, you can also set up soil pressure cases here as well. And we've got a new wizard that allows you to easily define soil pressures against things like basement walls within the program. If I hit OK, they'll be generated, and you can see all these combinations have just been quickly established and set up in here. You can play with the various factors if you wish. You can also add other load cases and combinations in here. So if I had something that wasn't automatically defined, maybe I've got a crane beam case, you can come and add this in here, okay, and you could assign you could assign these cases to various combinations. You can also edit the various safety factors that you wish to use. So once I've accepted that, I then have the ability to be able to assign the slabs. So let's just come in and key in a thickness of slab. The self-weight is automatically calculated. Now you can choose from libraries of finishes, and you can define these finishes in the building set-out page, so you can build up sections of different types of finishes. Maybe I've got a slab with screed and marble on it. I can come and choose that finish from here. Live loading, if I'm not sure about, if you right click, we can access the code. So you can see here guidance as to, for various occupancies, what type of loading, live loads that you should be defining. So this is just a guide here. So maybe it's bedrooms and dormitories that I wish to establish. And then you can just click where these may exist and then define those elements in the model. Of course, you can key your own values in here. We're not restricting you. Maybe you've got a toilet area with a different type of finish that you wish to set up. You can assign those. Maybe you've got other areas where you've got other types of loading. So all of this you can easily define in the model. Maybe the lift core there, the lobby there, the loading's a bit higher. Elsewhere, maybe that reduces. So you can just come in and establish these loads very quickly within the model here. Now you'll notice that as we've been doing this, we've been automatically creating yield lines. Okay. Now the yield line allows us to very accurately distribute loading to the members. So if I come and click Edit Loads, you'll see that even at this point, without us having done any analysis or anything, we've already started to distribute loading. So we have a very accurate model for allowing us to take irregular slab shapes like you have in this building here and accurately distribute loads. Now, if a situation arises where maybe I have a flat slab model or something a little bit different, I can use a finite element distribution instead of a yield line. So the choice is yours. Depending on what you're setting up here, you can create and establish different ways of distributing load. You can also play with the load distribution. So if you want to have one-way load distributions for, say, precast elements, that type of slab systems, you can easily define those in here as well. Now, as part of this, you'll also notice that you can assign other loads to the elements. So we've evolved this since the 2023 version to provide you with a fully flexible loading manager here. And in here you can set up and create other types of loading. So I may wish to define a wall load. Again, I can draw from libraries that I may have set up with different types of wall loading. It might be a 200mm thick brick wall, for example. We can set this up in here. We can then type in the height of that wall, and if we just click on the member, then that's instantly assigned to that beam. So if I hit OK, you'll see that loading's now been set up on the model. I can take this load and we can copy. And I can then choose to copy this load, and I can choose other elements that I'd like to replicate that to. So I can just select elements. I can box around. I can quickly come and choose where I want these to be placed, and then it's just a copy and paste function, and you can see that that's quickly been replicated around the perimeter of most of the perimeter of this plan. Now let's come and have a look at this this model in more detail. Now you'll notice that I've been working in plan, but what we've actually been doing is creating a full 3D physical model here. So I can see the physical model. You can visualize this. You can look at different aspects of the model. So if you want to look at from different perspectives, okay, you can. You can also tile views. So I can have both my plan view together with my 3D physical model view. Now once I've defined that, you'll notice that just earlier then I had defined the wall loading. I may want to complete the wall loading around the building. I can insert wall loads also by dragging. So if I just want to place a wall load to a certain location, I can be as accurate as I want here. So I can drag wall loads in. Okay, I can continue to do this. If I have maybe I've got a partial wall load along the beam, you can choose different points along that member, and you could just come and define that partially as well. So you can be as accurate as you like here with how these are set up and defined. Other aspects of the modelling that you can also take advantage of is things like openings and drops. So if I have penetrations through things like slabs, I can easily come in and define these. You can choose to define an opening, so it could be a rectangular opening like I've set up here. These can be easily manipulated. So if I had the position slightly wrong, these can easily be relocated to suit exactly how I want to see them. I may have other things going on in the slab. Perhaps I've got a drop or some other undulation that I wish to establish. It could be, for example, a set down in a bathroom, maybe for the wet area. Okay, that can easily be defined in the model here. The idea being that once you physically what you see here is exactly how the model will be defined and set up. So what you're trying to physically represent is what you'll create within the model here. I'm going to, at this stage, also insert openings, so we can define, say, an opening in the shear wall there. Okay, it could be a window or a door. Okay, that can easily be set up in here as well, and we can easily come and create. Now, that gives you an idea about how we go about creating a simple outline here. I may, at this point, want to insert a few floors. So let's just define a 5-story high building for this example. Okay, and I can then take this first story and we can start to generate information up. So I can copy that first floor and replicate that up the building. If I hit OK, that's being instantly generated up the model. Now the beauty with ProtaStructure is that you can make changes at any time to this model. So I may at this point wish to come up to the top level here, and I'm going to make some changes. So I'm going to delete the beams. Let's just assume that we no longer have any beams. I can just come and remove those, and I'm now left with a flat slab. Okay. So easily you can come and explore and create different structural systems in here that you'd like to work with. I can also at this point make some other changes. So I'm going to employ or use some of the new functionality that we've come with the 2024 release. I'm going to just come and place this column instead of this wall. So I'm just setting that up. I've inserted a column. Now in the new version, you also have the ability to be able to insert drop or slab patch panels together with this. And what I mean by this is I can define a slab drop. Okay, so maybe we've got an additional thickening here to the slab. It could be a 400 drop. But what I can also do is set up a patch as well around this, and now this patch will be used to integrate across this zone. The patch can be slightly bigger than the drop if we're looking at the spans either side and designing this as a flat slab. You can predefine these, and then you can then accept this. So we will integrate across these strip widths. We will then design the rebar within those strip widths and use this for our flat slab design. Now the same approach can also be employed in within a raft foundation. So you have the ability to be able to introduce upstand drops and take advantage of this. You can manipulate these for different parts of the slab. I'm just going to put one more in here. Okay, and let's just create these with those drops there. Now at the same stage, I can also set up and define strips that we may wish to look at for the analysis and design. So as part of the modelling, okay, we can assign slab strips, okay, and I can assign these in different directions. I'm going to start with the Y, and you can choose the way in which these will be detailed at the end. I'm going to use an FE strip, and we're going to use an integral strip. Now I can just come and choose where I'm going to place the strip here. So I'm placing the strip up and across this zone. And you can continue to define strips elsewhere. So if I wanted another strip in the Y direction up here, you'll notice that this may be my support band strip that I've created along grid line 4. In here I may wish to have a mid-band strip. I can play with the location of this by toggling with this arrow here. I can just choose the points over which I wish to integrate. Okay, and if I just hit update, you'll see that and if I choose the other side and hit update, you'll see that I'm now integrating across this entire width of panel. And I can continue to do this for other parts of the slab. So I can just come in here and define the various strips that I wish to create. Okay, and again I can just choose where I want to integrate, or over what width I wish to integrate to define the slab. Okay, you can just choose those points. If I hit update, you can see I'm just integrating across those zones. So it's quite easy to come in and set these up. Okay, and you can define the various strips and panels that you wish to consider. Okay, now I've done that in one direction. I could easily look at this in an alternative direction, so I'll just, for the purposes of this example, I will just show you another strip width in the X direction. Okay, and let's just cut this through these zones here. So let's just define a strip here, and I'll define one more strip up here. But you can see it's very easy to set up, and if I was going to complete this model, I would continue to define the various strips and various zones that I wish to set up for the slab design and detailing. So that's a simple way of setting up and defining a simple flat slab. Okay, model in here. I'm going to just jump down to, at this stage, I'm going to just jump down to the first story, and I'm going to also use another new functionality that we've introduced with this release, and this is composite elements. So I'm going to define a series of composite beams. Okay, I'm just removing some of the concrete elements that we have in here, and I'm then going to come and define these. So if you come to the steel element now, you'll notice that it's changed its name from what was traditionally called frame to now allowing you to define various types of steel elements. And these carry through not just for the modelling, but also we understand for the design processes what the element is, and various properties, various design processes would then be assigned to those elements when we're going through the analysis and design phases. So let's set up a primary composite beam. So we can come and choose the primary section here from the library. You can just predefine sections here. You can come and choose different steel profiles that you may wish to use. I might just grab a steel UB section that I like to define. Okay, and then I can just click between two elements and create that member. Okay, so you can see here I'm just setting that up and creating that. Okay, I may just remove this member as well. If you just want to go back and grab the properties of the previous sections, you can just select the element and then load the properties, and then I can continue. So I've just set up some primary composite beams here. I'm now going to set up some secondary composite members, but the way I'm going to do this is use the new option called frame groups. And what this allows me to do is create lots of members very quickly within a boundary of elements. So I'm setting up and creating a secondary composite member. I can come and choose a profile that I may wish to start with checking, and then I can then use this in the model. So I'm going to create. You can choose the number of elements you wish to define. Maybe in this example we want 4 elements. You can remove various members, so the last member there would actually clash with the core wall. So I'm going to just delete the last member there, and I can then come in and choose the elements that the members that I wish to define. So let me just choose the 2 members. Okay, it's then created automatically these members within that area, and I could do the same thing with the next bay. Okay, and then it's come and created those secondary composite frame members. Now I've got the composite sections in, and you can visualize this. You can see what's going on in here, what I've created at that level. I now would like to come and define our composite slab. So I can click on the composite slab, and this can be defined in different ways. You can either choose 2 diagonal points, or you can insert using 4 points. If I just choose 2 diagonal points, you'll see that I can just span across here. Sorry, let me do that again. Come and choose, I'll insert using 4 points so you can understand the process. So you can just bound the area which you would like to, where you'd like to define the composite slab, and then it will then define the deck. Now you have different ways in which the composite slab can be set up. So you can see here that this slab, the top of slab is actually coinciding with the top flange of this UB. You can though choose to manipulate this. So instead of this being aligned with the section, which is one option for setting this up, I can have this sitting above the flange. Okay. Now what you'll also notice at the same time is that we are automatically calculating the effective widths. So we are understanding that this is a composite slab, and we are automatically calculating the effective widths to be used in the design. Now, as part of this process, we'll also define maybe some steel that we wish to have, some mesh that we wish to use in the slab. We can also define a construction stage loading and we will run separately a construction load case. I'm also going to define some superimposed dead load as well as my live load. Okay, so once we have established this, we can then accept this, and then the composite slab will be set up. Now at the same time, we've actually dropped those slabs, those UBs in the model, so that the top of slab is still coinciding with the top of slab and other parts of the model there. Okay, so you can see that's been nicely set up and defined. Now while we're looking at this planar perspective, you'll notice that the orientation of the slab and the decking system is highlighted to you in the plan. Now if you go back into this, if I just go back into this, you can revisit this, you can change this. So if I wanted this to be composite in the other directions for the secondary members, okay, I can come and do this. You can also come and choose different types of decking profiles, so you can come in and choose your preference here, and there's a range of different decking profiles that we've preloaded in here that you can select and choose from that are easily accessible. So at the same time, I'm also going to just increase the thickness of the slab a bit there, so if I hit OK, then that's done. So quickly we've come and defined that, it's set up in the model. Okay, I'm now going to just move to a different perspective. So let's just let's change our view. So I'm just going to look at the 3D view of the model, looking at the entire building, and I'm going to move now up to the 5th floor. And what I like to do now is start to define some other steelwork in the building. Now to do this, we will choose from the steelwork elements in the modelling pane. The first thing I'm going to define is some columns. You can come and choose column sections from the library, so you can come and choose a section that you may wish to use, and then that section then becomes available for you to model. So I'm going to create some column sections here. I'm just dragging them through. What we also have within the steel modelling is what we call contextual modelling. So if I wish to create, for example, a truss element, I can just choose 2 points within the plane of where I'd like to define the truss, and it will then I'll then be presented with a library of various section truss profiles here that I might want to use. So you can use the predefined ones. These geometries can be manipulated, so if things are offset or slightly different, you can come and define these in here. You can have user-defined trusses, so if you wish to key in trusses like you would traditionally with nodes and define various elements like the top and bottom chords and the diagonals and bracing, you can do all of this as well. So you can set up these trusses within the library and you can reuse these. You can also define a geometrical arrangement from CAD. You can import this, so if you have some unusual geometry, you can come and set that up in here and take advantage of that. So I'm just going to grab a truss here. Let's just assume it's aligned at the top chord. You can see a little preview here of what this is actually ultimately going to look like. You can play with the number of bays, so if you wish to increase those, for example, you can do so. Okay, and you can see that on the fly that's being manipulated. You can, if you have large trusses, define splice positions. The splice coordinates will be passed through. Positions will be passed through to ProtaSteel, and that will allow us to affect the detailing of those connections. The members here, that can also be manipulated. So at the moment I've got angles, but if I wanted to change them to other types of sections, T's or tubular sections, for example, or maybe in this case maybe I'd like to use back-to-back angles, I can easily come and define these, and you can come and manipulate these here. Now you'll also notice that you have, as part of this, you can also play with all the fixities, so whether it's axial releases, torsional releases, fixities, all of these can be manipulated. If you're happy with this, if you just accept that, then the truss will be created. Now the truss will then become available for you to replicate elsewhere. So you can see that I'm just copying this off across the top of the building there. I can also come and define other elements. So I'm now going to work with a steel beam. We can come into the library, choose a section that we would like to start with. Okay, we can also play with the fixities here. So you can see I'm pinning both ends of the member. When we define these, you'll see that I'm just going to drag this through to the end column. It understands that there's all these other elements here, so it's asking me whether I should split those. I'll split those members, and those members are all now individual members, and they've all been pinned. Okay, so I can easily come in and define this. Now, at the top of the apex there, I may wish to select a different section. Let's use a tubular section for this. Okay, we can come and define that. You can play with the geometries here, and you can then come and define the section. So I can just choose between 2 points there and set those up. Okay, and let me just use that last point, so that's been easily defined. Now, as I mentioned, we are using these contextual elements, so the next step might be for me to take advantage of using braces. So I can just choose 2 elements to define a brace. You've got different types of bracing systems here that you can employ, so just depending on whether you're wanting to just have a basic diagonal or maybe a K-brace, you can just select from the library here. Again, you can manipulate the properties here or the geometries. Okay, if you want to play with the section sizes, maybe using rods or angles, or in this case a tubular section, it's easy for you to just come in and play with this to suit. So if you're happy with this, you can then accept that, and that will then be created in the model. Similarly, over this side, I can do the same thing. Again, we can just accept that, and that gets set up. If I come to the roof here, I can also just choose 2 trusses there, and it will also propose to me a bracing arrangement. Okay, and again, I can manipulate this. I can just key in the number of braces that we wish to have. Maybe in this situation here, I just want to brace the top chord of the truss. I can come and do that. Okay, if I hit OK, then that will be established here. Now, for other types of elements, maybe I'm wanting to define things like purlins. I can just select 2 purlins, and it will propose to me an arrangement here. Now, I can I can do whatever I like. It could be by spacing, it could be on the top chord. It's entirely up to me. I may wish to also play with the profiles, and maybe I want to use a different channel section. I could also play with sag rods, and there's different ways sag rods could be set up here. So all this is just to help defining those types of elements quickly. So if I accept that, you'll see that those have been established now. We've now got the purlin sitting in the roof. I'm going to do the same thing with the girts, so we could define these in here. We can play with the spacing. Okay, again, we can choose different sections that we would like to use. Okay, if we're happy with the layouts, then that can be quickly established. And the beauty of these is that once you've got these established, you can also just select them and go back in and manipulate them as well. So it's very easy to adapt these to suit. Now, what I want to point out at this point, this stage, is that we have created a real physical model. So everything you see here is physical, and we're essentially trying to define exactly what we're ultimately going to build. Okay, and you can see all the geometry that's been defined here, that this is actually looking physically like what we will ultimately build. This is very important because this will then help us to drive both the design and the detailing, as well as topics downstream like BIM integration. We can also in the model set up cladding planes. So here, if I choose the roof that I was looking at earlier, if I come back to the modelling, we can create cladding here. Okay, we can just define a cladding plane. We can accept that, and then once you've got this cladding plane in, you can come and edit the loads. So if you wish to define other types of loading on here, maybe it's just the self-weight of the cladding system that you're using, perhaps it's some live load, okay, and maybe it's 0.25 kilonewtons for sort of non-accessible roof. It could be other things in here, it could be wind loading and the like, so you can just easily come and choose those cladding planes and use those to help you define pressure loading. So it kind of gives you an idea about how we go about creating various items within ProtaStructure. Yeah, I've built a simple model here. Some of you may have seen this before, but I've also employed within that model a composite system. I've also looked at a partial flat slab. It's very flexible. You're able to easily come and define and create different types of models to suit the different nature of projects that you would typically get involved with. So at this point in time, I'm going to move into the loading. I'm going to come in and establish my different load cases. My different load permutations. I'm going to set up and create some seismic loading in this model. Earlier you'd mentioned that I was looking at medium ductility, and I can come in and choose different types of medium ductile systems here. And you can come and choose what kind of lateral load resisting system you wish. For this release, for the Eurocodes, you'll notice that you can have different structural systems in different directions, and these can be defined here. And the associated level of ductility as well as the detailing will also be performed. For many of the codes around the world, we also have seismic maps that you can draw from. This is Malaysia, for example, but if you're working in India or you're working in Indonesia or the Philippines, there's other maps available to you as well that you can draw from to provide you with guidance. This just steps through the code. You can choose the importance factor of the nature of the building that you're working with. You can also choose the underlying soil type. So if this was a softer soil, you'll see that these will be modified. If it's a stiffer soil, again, the spectral curve will adapt to suit. You can also choose the number of modes that you wish to run for any given model. We do some very sophisticated irregularity checks, so we'll be checking for irregularities in plan, torsional irregularities. If they exceed code specified limits, so normally that's 5%, the analysis will then iterate and apply appropriate penalties. As well as irregularities in elevation. So these are due to big differentials in mass as well as stiffness. The software will pick these up and assess them as part of the loading. We also will perform other checks on the model, strong column, weak beam, joint shear checks as part of them. We will automatically scale the base shear against the equivalent static load. So these are processes that can take a tremendous amount of time. And most programs that don't automate, software doesn't automate this, and these can save you a tremendous amount of time over having to do these manually. So I can accept this. Okay, I'm also at this stage going to assign wind loads. So again, we can come in and define the wind loading in here. Okay, we can key in basic parameters like wind speeds, terrain categories, as well as structural systems which affect the wind loading will all be defined. If you've got openings or dominant openings and the like, these can be established. We will then automatically work out the pressures that need to be defined against the model. So these can be applied. You can also, if you have spreadsheets, Excel sheets, you can bring these in and assign these to the model. Now, I've set up and assigned my basic loads. I've now defined sort of seismic and wind loading. Before I get to doing the analysis, we can just come and quickly check some of this. So if I'd like to see, okay, what live loading have I assigned to the model? You can easily come and review this. If I'd like to know what superimposed dead loads or what grades of materials I'm using, or perhaps what column section sizes I have. It's easy just to come and review and check this off before you actually get into the process of detailed design. So it's a nice way to be able to check the structure before we finalise it and move into the analysis and design processes. So the analysis, you'll notice there's a range of different types of analyses here. I'm just going to do a general building analysis at this point. I'm going to, the parameters that we set up earlier we can change. You can also come and manipulate the grades of steel and concrete. This is completely customizable, so if you have a preference for different bar sizes, for example, different grades of steel, these can be set. You can add your own grades in as well if you are doing building assessment and wanting to review an old building with different material grades. All these can be predefined here. The model options, you can play with and use crack section properties. For the Euro codes, these aren't required, but for the American codes, these will automatically adapt to suit those section properties, those crack section properties, and you can accept those. I'm going to use rigid zones, and you can define 25 or 50% reduction in rigidity if you wish. Beams can be defined as a flange or rectangular. You can, if you've already got foundations set up, if I'd already defined a raft, for example, these can be merged into the model and run at this point in time. You don't need to run the analysis twice. You can just merge the model in together with the soil springs, and we'll integrate that foundation in together with the model. Are you going to use shelves for the walls? I can also come in here and selectively choose to mesh parts of the model. So I was going to mesh the fourth floor where we define that flat slab. That's going to be meshed. I can use and define and mesh other parts of the model if I wish. It's entirely up to me. I can mesh the entire building if that's what I wish to do. Now the analysis is a button. Okay, and I'm just going to now run this, and at the same time I'm going to perform the design. So if we just hit accept this and then hit go, you'll see that it's now creating that physical model, and it's going to automatically create and run the analysis. So the analysis has been completed. There's a number of post-analysis checks that we perform to ensure that the structure, the integrity of the structure is okay. For example, we'll check for interstory drift checks. We will add up the weight of each floor as you would manually and compare it with the analysis reactions. These types of checks are done simultaneously, and there will be a report here advising you of any of the impacts of those checks. Post-analysis, there are also other reports that you can refer to. So there's the post-analysis check report. This is a good starting point, particularly if you're looking at earthquake design, and this will provide you with insight into the behaviour of the structure. You can look at things like whether the structure is torsionally flexible, mass participation checks would be performed, relative story drift checks and the like. So there's a lot of detail being driven as we're running this analysis process, and these are all available on the various reports that we will produce. Now, post-analysis, you can come and have a look at the analytical model. So I'm going to look at the building model here. So we can open this up. Here you can see the model. Think of this a little bit like a typical model that you might see in any general analysis program. You can come in and choose to look at different aspects of this. I've just turned the nodes off there. If I'd like to see, for example, maybe I'd like to see the axial load that's occurring in the column, or if I'm interested in looking at the moments that are in the beams, I can come in and visualize and see these behaviors here. What I can also do is show detailed diagrams. So here I can see, I can drill in and look at a particular element. Here I can see the shear and moment acting on that beam. I can look at it for various different combinations here, or load cases and combinations. I can also look at for the entire envelope of that element. If I just wanted to focus in on, say, dead plus live, I could do so. If I wish to look at, say, maybe the deflection along that member, the relative deflection, I can review that as well. If I'd like to see if there's any torsion acting in the member, again, I can quickly come and review. So it's a nice way to be able to work your way around the model and interrogate different aspects of the model that you might be interested in. I can also, at this point, come and have a look at the maybe the contours in the building. So we could choose a particular combination that we're interested in, and we can look at various stress contours here. Okay, at the moment I've got both the walls and the slab shown, but I may just wish to focus in on the slab, so we can just ask to look at interrogating this. You can, of course, look at envelopes as well, but within this you'll notice that you've got various stress contours that you can look at here. You can also look at shear now in the slab, so you can see relevant shear stresses that are in the slab, and you can also get down into looking at moments. So you can look at design moments, which include wood armour effects. So these are the moments in various directions, top and bottom. Okay, and you can see the concentration of moment across that flat slab, which is as we would expect in the zones that we were looking at. We can also see what this may be in terms of area of steel. So you can look at what the equivalent area of steel may be in those zones, and you get an idea of what the requirements are based on this. This legend here. Now these contours can be exported back to the key plans, and you can overlay these to get a feel for what the design steel may be in different parts of, for example, a flat slab or a raft, and you could then use this as a guide to help you define the patch contours that I set up earlier. So that's one way in which that could be utilised. Now, I may, at this point, want to just have a look at the overall behaviour of the model. Okay, if I go back to the results here, we may want to see how the building's behaving under various loadings. So it might be, for example, I'd like to see the behaviour under say seismic, for example, so we can see the dynamic behaviour here. Okay, this renders very quickly. You can look at different aspects of the building and how it might be behaving under different types of loading. Okay, this can be quickly shown here, so you can get a feel for various behaviours. Okay, you can also look at the modal behaviour of the structure. So I ran a number of different modes there, so you can see the fundamental period here in the Y direction and the X direction. We will work these out. Okay, for the model. So again, you can get a feel for the behaviour here and make sure that you're happy with how the response of the structural system. At this point in time, I'm just going to come back, and we can now take a look at the design. So as we ran that the model, we actually designed the structure, and you can come and just look at the design status. You can see the majority of that's been designed there. Okay, you can just see an overview of the building there. You can come and interrogate where things haven't been designed, but quickly you can see that the structure there is designed. And I can come and have a look at different aspects of this design. So I may wish to look at a particular section of the beam in particular. I can come and dig into this. So this is a continuous beam with a curved section. Here you can of course have a look at the details of this, so you can see the envelope that we're using for the design of this. Okay, you can also see a schematic of all the bars that we've chosen. So these are being selected on the fly as we optimize the design of the member. With this release, we now also provide detailed design reports, so you can see a lot of the detailed checks that we will perform as part of the code checking. So if I select a member and I want to see a very detailed report, this is now available in ProtaStructure, and we will provide a significant amount of detail here, including step-by-step calculations. So all the relevant code course referencing will be provided, and you can see step by step how we're going about designing these sections. So if you're wanting more detailed insight into how we're going about performing these checks, all this information is now provided as part of this new reporting. Okay. Now these checks extend to other aspects of the design. You'll see these reports available in the foundations. You'll also see these reports available in the steel design and composite design, which I'll get to in a minute. So it's a very nice way to be able to interrogate the report. The design makes sure that it's providing insight into what you're doing and giving you all the detail that you need. Now these can be compiled together with the submissions. Of course, you still have the ability to just be able to create summary reports. So if you just want, in general, summary reports, but then you want to, for certain key elements, add detailed reports in, you can also do this. Now there are other reports that we're providing here and other checks that we can do. So for example, I want to see the joint shear check for this member. I can click on this, and again it's producing the joint shear check along that axis, and we're looking at the various joints and constraints that are being provided and checking the shear there. So it'll understand whether this is confined or not, and appropriate checks will be performed. Similarly, for strong column weak beam checks, again we'll also perform these. Okay, and you can see whether they've passed or not. Okay, there'll be various checks that will be provided here. Okay, and you can manipulate the steel to satisfy those checks if that's important to you. Okay, so I've shown you the individual element design. The design is actually all loaded up in one place. So if I come and click on, say for example, columns here, I can see that all the sections are designed in here, and again I can come and interrogate these. So if I wish to just check maybe that wall that we had designed earlier, a wall element, you can see what's critical in the design. You can look at interaction plots. We will calculate the neutral axis location of a kind of wall or a column, and we will work out the exact location of the bars relative to that, and we will work out capacities accordingly. Okay, so all this is being done on the go. You can see interaction diagrams here also. Similar plots are produced for the columns. And even at this point, you can start to actually get a feel for what the detailing might look like for, say, this wall. So here you can see a quick elevation of that wall together with the openings there, and we actually had those columns with the drop head panels at the top there. So again, quickly you can come and see and interrogate and review that information. If I pop into the composite beams, you can see that these have all been designed as well. You can click on maybe the primary composite section, and you can see the section here with all the studs in it. All the various checks have been performed in accordance with the code. Okay, and you can delve in and also see a detailed design report here, so you can see all the various checks that we're doing in accordance with the code with step-by-step documentation. This also includes us looking at stage construction analysis. So before, when we run the analysis, we actually did two analyses simultaneously. We did a subframe analysis where the structure was effectively pinned, and we were looking at the staging for the composite. So this is the construction stage case. And then we looked at the entire model together with the final case for the composite. All of that's being handled in one analytical run. And again, you can see the various checks that we're performing here to satisfy the code. This also goes down into checking final checks for things like vibration checks and so on, which will be carried out in accordance with the Eurocode. So that's a nice new capabilities in the software, a great new feature for designing composite systems. It's quite nice and easy to use. It supports a wide range of different decking profiles. It supports both simple and continuous composite construction, and it also provides you with comprehensive documentation for your submissions. Now if we come back up to our roof plan, you'll recall that I had created flat slab at level 4. Okay, you'll notice now that we've actually, as part of the design process, we've actually sized up the reinforcement in these panels. The reinforcement can be drawn from either the building analysis model or the FE floor model. Probably in this situation, if I was not drawing it from the building analysis model, I'd take it from the FE floor model, and I could make adjustments for creep and shrinkage effects if I wish. But I've drawn this from that model. Now, what we've actually done here as part of this process is that, as I mentioned to you before, we've defined our patch zones. I've also got a drop head panel in there. We're integrating across these patch zones in both directions, and we are providing, designing the additional reinforcement that's required in these areas. So you can see that there. These other strips in between, we are just looking along those strips and integrating across these widths and working out what reinforcement is required in these zones. So now we've got a really nice solution for facilitating flat slab design and detailing. So you can see all the bars are being laid out there across the strips that I've designed. You can come in and look at this in more detail, so if you do want to see the reinforcement requirements, you can see the design of the patches here, and you can see that they're passing for those zones. So this is just being automated. This information is also fed into their punching shear check. So if I did just select these two elements, and I am just going to come and run the punching shear check, so you can see that we've automatically picked up the reinforcement that we had provided as part of that slab design, and you can see that we've checked those perimeters and they're adequate. And you've got the detailed checks there, and this is in accordance with this is in accordance with the Euro codes for these particular checks. So and they're summarised there. So if you close that down, you can see the zones. If you needed additional shear steel, that will be highlighted in the plan views here, and you'll see notation with additional shear steel that need to be provided. That could be provided either with links, or you may wish to increase the number of longitudinal bars that you have here. Okay. Now I've just shown you this as an example. I know it's not the best example in the world. Often these areas at the edge there would fail. If I was going to do this again, I would have put this slab in further around the perimeter, and I could just define that by a polyline slab and then put that slab across the whole area there. But I just wanted to give you an idea about how this new functionality works and how you can take advantage of it within your flat slab projects. So we've now designed the superstructure, and you can see that in here. We've covered the slabs. We've also designed the story beams there. There's one or two that I probably need to just have a quick look at, but they're designed. Just so you're aware, there's also grouping functionality in here as well. So if I do want to group members into groups, I can do that, and then we will document and design those accordingly. So that's a nice feature as well, especially if you wish to rationalise the design. Now I'm at this point going to just jump down to the foundation level, so we can just click on ST0, and I'm going to just come and select these perimeter columns here. Now we've collated underneath this all the analytical reactions from the analysis model, and I can at this point come and insert either pad footings or pile caps. Now you can play with the parameters for the pile caps, so if you wanted to play with various settings in here, you can do so. If you want to key in the ultimate compression capacity of the pile, which is to Eurocode, you can manipulate this. You can also play with the pile sizes as your defaults, and you can then come and design these. So I'm just going to come and batch design the foundations here. Okay. I can see that one or two of these aren't working. Okay. You can come and manipulate the bar sizes and see if that helps. So it has. I managed to make that work. It was just iterating, so I can accept it. Okay, similarly with this, I might be a similar scenario where I just want to up the reinforcement. So you can play with this to suit. Okay, so I've just got the punching shear perimeter is slightly failed. You could deal with this in a number of ways. Maybe you want to just see if I go slightly deeper, if that's going to work. Yes, that's okay, and I can accept that. So you can iterate within this to help you come up with a design that satisfies the parameters. Now, these piling systems can be grouped, so I'll automatically find those piles that are similar, and if you hit OK, then the pile caps will be created. Okay, now these are each of these pile caps you can come in and manipulate. So if I choose this pile cap here and I go to the properties, you can see the layouts here. Now what you could do is, if you find that, for example, piles are moving around on site, okay, and you want to define things like eccentricities, you can do so, and we will automatically check these to see whether they satisfy the code. Okay, and if you accepted that, then you can see that these have been updated with the as-built position. So that's a nice way that you can deal with sort of pile cap design here. If I continue to select these other elements here, okay, I might wish to at this point come in and insert maybe we would like to create some pad foundations. So let me just grab those again. So just grab these, come in, and if you right click, you can insert the pad footings this time around. Okay, and again we can feed in parameters like the allowable bearing pressure, and we can just come in and design these systems. So it's just going to go through and check all the various permutations that we've loaded in terms of the combinations. So just give it a second here, and that will then take those and design them. Okay, so you can see that they're all been designed, and again we can accept those. There's also new detailed design documentation around this that you can take advantage of. The final thing in here I may do is just create maybe a foundation system. So similar to what I did with the flat slab, we can come in and define a raft foundation. You can come in and set this up in here. So the I'm going to just insert this by beam region, and then that will be defined in the model. Okay, so, and I could insert piles in here. I can insert upstands like I showed you previously. And you can use this for both the columns as well as the walls. So you could put a patch around that if you wished, and create an upstand if you're worried about shear capacity. So very quickly, I've created a complete building model here. At this point in time, I may wish to look at how we go about documenting this. So I'm just going to save this model, and I'm then going to move this into ProtaDetails. Okay, so I'm going to launch ProtaDetails directly from ProtaStructure. These are integral. The architecture, the underlying software architecture is common, and I'm just going to launch this, and we're going to move straight into our the 2024 version of ProtaDetails. Now this is where the magic happens within the software. I'm now going to take this, and I'm going to ask the system to document. So I'm going to ask it to automatically generate the drawings. I can choose what it is I want to document here. I'm going to insert into a sheet. This would be your title block. You can reference and label these sheets however you wish. Okay, if you wish to, of course, make changes to the way that things like beams and so on are truncated, you can. You can play with the scale of details. All of this is customizable. Think of it as you're in a CAD system. You have complete control over the layers, line types, the scales, the fonts, everything that you wish to get this looking the way that you want to see your drawings. So I'm just going to hit go, and it's going to take those details, and then it's going to move to document all of this. Okay, so you can see it's working away here. It's starting to process all that information that we've provided to it. You will notice along the top there that this is actually a DWG file. So natively we're working in DWG format, and you can see there that it started to create what is a foundation plan. Okay, if we just give it a few more seconds, you'll see that it will finish, and we can see all the documentation. But even at this point, you can see that the layers, the line types that are used for the set out of those foundation drawings are sort of covering standard convention with how things will look. So if I just come back out, you can see that we've now created all these drawings in one go. Okay, they've all been documented out. And I can come in and look at these in more detail, so we can see our foundation drawings. Okay, that includes that pile cap where we've got eccentric information shown. We've got our first story, and you can see some of the composite details there. You can also see the key plans, so these are being laid out, including openings and drops. Okay, you can also see these have been laid into your title block, so everything's being referenced against what would be your standard title block. And here's also the detailing that we created earlier for the flat slab details that we set up. Okay, so all of this is being documented directly into the drawings. You can provide other levels of details. So here you can see I have set out drawings where we're setting out elements against grid. You can also see the smart containment that we've been doing here for the walls, so you can show those in this area. There's also other little details being provided here, so you can see elevations of those wall sections. You can also see the openings in that singular wall with the trimmer bars around those. Okay, if you'd like to see the detailing for the columns, you can see here we've employed ductile detailing for these, so you can see the plastic hinge zone detailing is being employed, this being a structure with medium ductility. Okay, so you can draw these in elevation. You can also show information in plan views, so in schedules. So here you can see column schedules. You've got all the different bar types here, column sizes. So column references are all shown here. These are automatically grouped, so things that are similar are automatically being grouped into these here. Similarly, you can see the wall details as well. Okay. Now moving down, you can move into having a look at the beam details. Beams that are similar have been automatically grouped. Okay, and you'll also see here that we've employed ductile detailing for the beams. Okay, if you were not in a high seismic zone, then we would just employ conventional detailing. This is the beauty of the system. Depending on the nature of the design that you're having to engage, we will design and detail things accordingly. So all the members here have been grouped. Okay, you can see that they've been grouped. If members get too long, we will automatically truncate, and we will continue to develop the details. So you can see some of those profiles there and how they've been drawn out. Now, if you do look at a member, you'll notice here that there are so I go back to that. There are 3H16s. It's positional mark 4. If you come over to the table here, you'll see there's 16s. There's 3 of them. There's 7.45 metres in total. It's 22.35 metres altogether, and you can see the bar bending schedule here. So you'll notice that all the different bars for this particular sheet, including torsional links and laps, are all being broken out here. So they're all being created. Okay, and at the same time, you can also see the full tonnage for this drawing. So that includes everything, laps, links, everything's been quantified here. There's 3.54 tonnes of steel. If you're comparing different schemes, this is very useful because at a glance you'll know you can compare different structural systems and work out what's the most efficient, perhaps what's the most economical approach for your building. These are objects, so you can make changes to the drawings here. So if this element was no longer a 16 but you wanted to make it a 25, you can come in here and adapt this. And these are dynamic, so when you do this, the details will update, and you can see that that's now a big change to a 25. Simultaneously, we will also recalculate. So you can see I've now got 3.67 tonnes of steel. So this is all dynamic, it's live. If you do make little tweaks to the detailing there, this will be carried through with your drawings and your quantity schedules. If you come down, you can also see the foundation details. So you can see our pad footings as well as our pile caps. Okay, so they've all been, the drawings for those have also been produced. With this version, there's also a new feature where you can actually create your pad footing and pile cap rebar schedule. So if you did want to just populate this into the drawing, you can. So you can actually see a schedule rather than seeing all the detailed drawings there. So that's a nice way to be able to simplify the presentation of information if that's what you need. We also provide this for the beams as well, so you can see the beams produced in a schedule, and similar beams will also be marked in here. So that's another nice way of being able to simplify information if you're not required to provide all the detail. So that gives you a quick overview of ProtaDetails. There's many more things in ProtaDetails that I could talk about. We have a comprehensive design and detail library here where you can not design and detail other elements within your project. You can also draw up other elements in here, whether it's culverts or pit foundations and so on. You can add details into these drawings. You can happily draft in here, modify things in here to suit. It is a complete CAD system, so if you do want to pick details up, move them around, reposition things, all of this is easily done in the platform. If you want to cut, curtail, make changes in here, you can. All this is at your you can easily come in and achieve. So it's a really nice platform for producing all your drawings, automating all the drawing production, and creating everything in one. But we also have some very other special tools in here for helping you do component design and detailing. The final thing I'm going to touch on today is ProtaSteel. So once we've done the design and the analysis and design of all the steelwork in ProtaStructure, we can then take this out to ProtaSteel. We can then move in and start to look at the design and detailing of all the steelwork, including the connections. So I'm just launching ProtaSteel here. Again, it's just seamlessly integrated into the platform. Okay, I'll just take the model and we'll open this up. And here we are in the ProtaSteel environment. So what you'll notice along to the left here is that there's a whole what we call macro gallery, and these are a range of different connections that we both design and detail within ProtaSteel. So we've communicated the entire model from ProtaStructure. This includes all the underlying analytical reactions. It's being communicated into here. You can see that there's a broad range of different types of connections here, from things like stiffen end plates, fin plates, back-to-back beam-to-beam end plates, angle cleats, apex haunches. If you've got beam-to-column connections, there's similar arrangement there, but including welded joints as well as haunches, as well as even beam-to-wall connections. There's a new knee connection with the 2024 version that you could take advantage of. There's also bracing connections in here, splice connections that you can use, purlin and girt connections, as well as base plate connections. We've continued to enhance and add connections in here. You'll also see the new RC columns truss seating connection that you can use and explore. Okay, but the idea is in here there's a range of different macros that we have developed that allow you to design and detail a wide range of different steelwork very quickly. So and that includes the floor, checker plates, as well as railings, as well as staircases, all sorts of things that you can do in here to complement the steel model from ProtaStructure. So the way this works is that you can just come in and choose a macro. It could be as simple as a purlin macro. You can choose and select two elements, and if you right click, it will assign that macro to the model. So I'm just right clicking here, and it's going away and designing those purlins and connecting them directly to the truss. Okay, and you can run along and do that very, very quickly and design those elements. Each of these macros has functionality within it. So if I just select the macro itself and I hit M and enter, then it'll open up all the different preferences within the macro. You can change the preferences, so if you want a bracket type with or without cuts, for example, or a folded plate, or maybe you wanted this actually drawn from the same profile. So you have different macro preferences here that you can choose from to suit the project that you're working on. So each macro has a range of different connections associated with it, a lot of flexibility built into how you go about choosing the preferences for your connection design. If I come to the beam to column connection, again I can choose an appropriate connection here, right click, and we can create that connection here. And that's a beam to end connect. Now what we're doing underneath this is we're also coming and designing. So I've designed this to Eurocode. At the same time, we're also designing this connection, and you can see in detail here the documentation around the connection there. So we're feeding all the forces into this, and this is being documented step by step, and you can see all the detailed design calculations that we're preparing for the connections to satisfy the code of practice. So whether you're designing it to the British standards, whether you're designing it to Eurocode or the US codes, there's a range of different codes of practice that we support within ProtaSteel. Now, in the interest of saving time, I'm going to just come in and show you our revolutionary IntelliConnect. So I can select the model, I can go to IntelliConnect, and in here I can design things like purlin, girt, sag rods, truss connections and so on very quickly. So if I wanted to design the girt connections, for example, I can choose a preference here. I can choose, I can add in additional offsets, and I can just run it and it'll come in and batch design all those connections for me. Okay, I can carry on. If I wanted to do the sag rods, I'll do this, and then I'll come in and show you the model. But we are at this point coming in and batch designing a range of different connections. So this will complement what else I've designed here. So I have. So if you come in now, you can see that we've picked up and we've designed numerous connections here. I did take the liberty of designing some of the truss connections as well earlier, and you can see that we've performed the connection design for a range of different elements within the model. Now at this point, if I want to come in and document things, I can come in and we can select a connection. So if I wanted to document this connection at the end here, we can come and choose Detail Item Manager. I can give this a name, call it Truss 1. We can add this, and then we can select the objects that we want to have within the connection. So we then can take different snapshots of this connection. I can choose different perspectives and views that I might want to see of it. So you can just run around and choose the different perspectives that you'd like annotated in the drawing. Okay, and then you can accept that. Now, I can choose other parts of the model. So maybe I'd like to detail out a purlin connection, for example. So again, similarly, I can choose the Detail Item Manager. I can add the item. So just let's just give it a name. So we can call it Purlin Connection 1. We can add that, and we can choose the objects that we want to see in there. And again, you've got different perspectives that you can cut through the model here. So I may be looking at an elevation from this end, and maybe at the end on. I can also add in 3D perspectives into the connections as well if I wished, so they can be added in to complement the detailing. So once we've got these, the final step in this process is to actually come in and create drawings. And the way we do this is we take views, or we cut views through this to create the different perspectives. So I'm just going to cut an elevation through the model. Here you can see an elevation of this. And I can then come in and create drawings. So I'm going to just open up the drawing manager. Okay, I'm going to just create a new drawing, and we can call this truss, for example. I can accept that, and you'll see that the trusses, you'll see that there's now a drawing sheet, and the elevation that we cut is created as a viewpoint. So I've just pulled that into the drawing sheet here. You'll notice now that there's a new ribbon here where you can work within ProtaSteel to annotate things. So if I wanted to annotate various things like maybe the purlins, I can come in and just start to annotate out the drawings the way that I'd like to present information. So it's entirely up to me how I do this, but very quickly you can come in and annotate out the steelwork. Now those views where we've taken the connections here, if we just if we go back to the annotation, or sorry, the tools, we can, if we just connect the connection detail drawings, if we just click on this, it will then provide the annotations for these. So across the left here, you can see that these have now been drawn out. These are just perspectives of that connection. So if I do want to just extend the detail a little bit, maybe I want to just move items in the connection around. All of these elements can be just manipulated to suit how we want to see the drawings being prepared. You can also see 3D perspectives here, and other information is shown. Now these can be further annotated if you wish, if you want to add other types of annotation. I've shown you I may want to annotate the bolts, for example, so I can just select that, and we can ask it to provide annotation for the bolts. You can see the bolts are now referenced in here. I could further annotate things by adding other dimensions, so it's entirely up to me how I go about doing this, but you can just come and annotate this to suit and get the level of steelwork detailing that you desire on your project. Now at the same time, what we're also doing is we are annotating this back to that elevation, so you can see all the purling connections we know are similar. They've been annotated. Similarly, the truss connection is the same at the end here. So it understands this. These connections are being grouped and annotated accordingly. Okay, so that just gives you a quick insight into ProtaSteel and how it works. We do have other presentations that go into this in more detail. You can get to see a lot of the sort of the detailing technology behind this and how we go right down to fabrication. So it is really impressive. You can come and see different perspectives of the model in here, and you can let me just change this view, so we can look at different cuts and views and perspectives of this model. We can go right down to producing shop detailing using ProtaSteel. Now if you are interested in ProtaSteel, there's other videos available through our YouTube channel. Check them out. We'll leave some links in the description in this video which you can view, but we've got ProtaDetails is a really powerful system for design and detailing of all your steelwork right down to assembly and shop drawing detailing. Now these can be sent to other BIM platforms, so whether it's a DXF or an IFC, we also have a native link with Tekla if you wish to send out to that platform. Maybe you're working with a fabricator, and that will also send out the macros in an intelligent form, which they can continue to work with to refine the project. So that kind of gives you an idea of ProtaSteel and how that works, how this is changing the industry. If I just go back to our main model, obviously we've covered a lot of ground today. We've covered all the modelling, all the design and detailing of multiple different structural systems, composite, flat slabs, different foundation systems. We've also gone into all the documentation, creating all the drawings automatically in ProtaDetails, as well as producing all the steelwork detailing, connection details in ProtaSteel. So it's a fantastic tool for allowing you to design and detail projects extremely rapidly, extremely efficiently. I hope you've enjoyed today. We've covered a lot of ground. I just want to conclude by drawing your attention to the Prota Help Centre. A lot of the detail we've covered today and reference materials is available here. Check it out. There's a lot of detail in there. Check out our new AI bot too. Ask it questions. I'm sure it'll be able to help you with your designs. There's also the website. Come and refer to that. You can also connect to us through the website. If you're not a user of ProtaStructure, want to find out more, drop us a contact. We'd love to get in touch. You can also connect to us with our social media channels. I've touched on base the YouTube channel before. There's a bevy of different videos. A smorgasbord of information is available here for you to understand more about the Prota platform. Okay. Also connect with us online. Yeah, we'd love to connect with you, whether you're using LinkedIn, Facebook, Instagram, or X. Reach out to us, connect to us, find out and keep abreast of all the developments at Prota. If you're wanting to know more about sales, drop us an email directly, global sales or Asia sales at protasoftware.com, and can check out the website, continue to keep up to date with information from us. We'd love to hear from you. We'd love to hear feedback and know how all of our users out there are getting on using the platform. So thank you very much for today. I hope you enjoyed it. Stay in touch and turbocharge your project delivery with Prota and ProtaStructure 2024.